Hey everyone, and welcome to this evening. Well, depending on where you are in the world, but for me, it's this evening's second session of Exida's webinar. This evening, we're going to look at the FMEA to FMEDA process and basically trying to streamline that process, getting as much as we can from the FMEA to make sure that the FMEDA goes a lot smoother. So, better results, less hours. My name is Paddy Healy, and as always, a summary slide set will be available after this webinar. And as always as well, the recordings are made available both through Exida's website and our YouTube channel. So as I said, we're going to go through the process today, what data we need to get out of the FMEA to make sure that our FMEDA goes a lot smoother and that we don't have to go back and do any iterations through this process. So this is the fifth webinar in the fall or autumn FMEA webinar series. Dr. William Goebel brought you through the first three. You had me last week with integration test plans, and obviously today with the FMEA to FMEDA. Next week you will have Dr. Molly O'Brien, and she'll be looking at a streamlined FMEA and using a microcomputer example demo. So if you haven't already signed up, yeah, please sign up for that one. A little bit about Exida. The company was founded just over 23 years ago by several of the world's top reliability and safety experts, and professionals around the world are definitely knocking on our door every day looking for guidance through the whole journey of certification related to whether it's automation, functional safety, alarm management and cybersecurity. As you can see, in those 23 years, Exida has really grown to be a global company with offices dotted all throughout the world in every time zone. So wherever you are, we have someone there who's ready and awake and willing to chat to you and help you on your journey. So there are three kind of main areas within Exida, three departments as it were. We have the system lifecycle services. We have the certification and assessment, which I'm part of. So basically what we do is we help customers basically get their products certified and everything in between. And then we have the engineering tools division, which has its own in-house software development team, which bring you tools that you may be already familiar with, such as Excellentia and OEMX, which I use on a daily basis. And within OEMX, that's a suite of applications comprising of RecX, ArcX, and FMEDAX. And the core element within this particular suite of applications is the CRD, or the Component Reliability Database. Another huge kind of thing that Exida is proud to have is a massive library of reference materials. So whether that's in digital form or hard copy, there are many books available, obviously webinars such as this one, white papers, and obviously access to a lot of industry experts. But one that I just want to bring your attention to, and I mentioned it in the previous slide, is the CRD, or Component Reliability Database, and it actually comes in a hardback version as well. It's now in its 6th edition. So if you're in the kind of product development area, these books, this collection of books have every component that you will possibly need or use in your design. All the failure rates, the useful life, all that important information is in those books. But as I say, it's also part of our OEMX suite of tools. So what are the main objectives when we're doing design FMEA? As we've kind of touched on in the other webinars, the main ones are to find problems in the design, recommend mitigations in the designs, basically how can we fix the problem, update our requirements as those mitigations are chosen, define integration tests, which we looked at last week. What we're looking at today is providing what inputs do we need for the FMEDA. So what outputs do we take from the FMEA that will make the FMEDA process a lot smoother. Then document the design choices and train new staff members. And all this, the main kind of goal for all this is to reduce the number of engineering hours required to do this, and make sure that our project comes in under budget. So just looking at an example product development process, many people ask us where in this kind of very complex process and life cycle does the FMEA come in? And I suppose the simple answer to that is the earlier you can do the FMEA, the better. It'll reduce hours, reruns, iterations for your particular design, because you'll iron out any potential issues that may come down the line in both your system, your hardware, and your software, and then also linking that to what tests you need in your particular product development cycle. So just looking at kind of architecture levels, and again, another question that we get asked regularly is how kind of low you go in your architecture design for doing your FMEA. Again, there are many kind of different interpretations of what an FMEA is. Some people kind of do it at the system level, and they describe the failure modes at the system level and then try to apply them throughout their particular design. But what we like to do is to go to the lowest subsystem level that we possibly can, that basically has a common failure mode or modes within that particular block within our architecture. And it's at that point that we do our FMEA, and it makes for a much smoother FMEDA process. So looking at a little example here, this is our kind of device, our system level design. We have our power supply, we have our communications bus, we have various inputs to our microcontroller, and then we have various outputs. So picking on our power supply, our first kind of dive into the architecture level, the first subsystem we go to is the overall power supply. But within that power supply, you may have various different parts of it that are applied to different features within your design. Some of the power supply may provide power for your safety critical elements within your design. Others may be for diagnostics, some for the microprocessor, microcontroller. So each of those different kind of sub blocks within the power supply might deserve or need further kind of dive in for doing your FMEDA, or sorry, for your FMEA. So within this design here, this is our overall power supply, and we pick on one particular sub block within there, and we dive in, and that's where we do our FMEA, and in turn then our FMEDA. So what are the inputs? As I say, this is ultimately where what we're kind of looking to get from this this evening's webinar. What are the outputs from the FMEA to give us the correct inputs for the FMEDA? So the first ones we need to look for, obviously, are our hardware architecture. We need to create this, and by doing this in turn then gives us our hardware architecture drawing with description and failure modes of each block. The next thing, kind of going a little bit deeper then, is we need the detailed hardware design. And from this then we get our hardware schematic, drawing, our bill of materials, and component specifications. But is this enough? What more do I need when I'm doing my FMEDA? So kind of using a little example here, we have a particular component in our design, C19, it's a capacitor. It fails with a high leakage or short circuit, and in turn drops our 3.3 voltage to 0. What's the system impact of this? Is there any mechanism to detect the failure, or is this latent? We need to talk to the designer. However, the designer may not be available. He could be busy. He could be working on other tasks. However, if we get the correct information from our FMEA, we don't have to waste time looking to talk to the designer and figure out what information we need. So building on our hardware architecture and our detailed hardware design that we have here, some other outputs that we need to get from our FMEA are our device failure modes, and this gives us our safe state. Also, we need to get our derived requirements and design change recommendations, and this might lead to our list of automatic diagnostics. And then our latent fault mitigations, and this will give us our failure mode prevention, mitigations, and proof test procedures. So looking at another example for doing an FMEA leading to our FMEDA, this is our simple flasher circuit. Some of you may be already familiar with it. Here we have our architecture block diagram, our overall system level design. Each of these are our subsystem blocks, and for each of these subsystem blocks, we will ultimately be looking to describe our deviations and mitigations. Over here we have our block descriptions, so basically self-explanatory what each block does and basically how it reacts under certain situations. I suppose the main one to draw your attention to is that this input circuit it's de-energized to trip. I see, Bruce, a few questions coming up there, so I'll keep going, but we'll come back to them at the end. But yeah, no problem at all. So that's our block descriptions. And from that, then we can now start drawing our architecture, or sorry, our schematic, our detailed schematic design. As you can see here, we have our power input, and there's redundancy built in. These two op amps here act as comparators, and they will be our power diagnostics. Failure on either of these power lines will lead to our comparators going to a zero output or zero rail, in turn switching off the transistor, which in turn will cause this optocoupler to stop transmitting and will give a signal on this particular terminal here. We're assuming that this terminal is connecting to some type of logic, whether it's a PLC or some type of microcontroller. When it detects the zero voltage here, de-energized to trip, it instigates a signal on this terminal here, which in turn activates this optocoupler. And by activation of this optocoupler, this in turn activates this Schmidt trigger, which in turn causes our LED arrays to oscillate at a given frequency or duty cycle based on this RC circuit here. So when we're doing our FMEDA, and based from obviously our FMEA, there are a couple of ways that you can do this. One of which is the conventional FMEDA method, and this is direct mapping approach. Direct mapping of a component failure mode to a device failure mode. So it's either safe, dangerous, enunciation, or we don't care. It's faster in terms of actually carrying out the FMEDA, and it's quite, it kind of suits itself to using a non-specific tool such as a spreadsheet. However, if there are any issues or a redesign, it often requires a complete FMEDA review. And another disadvantage is that blocks within our design cannot be reused as readily as the functional failure approach. So that's what we're going to look at next. This is the other way of carrying out an FMEDA, the functional failure approach. And this, as I described earlier, is basically mapping or describing functional failure modes for each block in our design, each subsystem block in our design, describing the deviations and mitigations, and then mapping the failure of each component within that block to the failure modes within that block, not to a system level failure mode or deviation. And the advantage of that, as I said, it's obviously the opposite of our direct mapping approach. It means that we're very easily able to reuse blocks within our design when we're doing our FMEA. And it also means that if there's changes within our design, it's very easy to change just that particular block that we're doing the analysis on without having to do a complete rerun through our FMEDA. So looking back at our diagram as to what outputs we need from our FMEA to allow us to do a streamlined FMEDA, or a more, I won't say simplistic, but yeah, a more streamlined FMEDA. So the next addition to that is our block failure mode classifications. And as we looked at there, you can either use the direct or the functional mapping, whichever one you feel is more applicable. So looking at our flasher again, our flasher example, the hardware architecture blocks are entered, deviations, failure modes are created, and mitigations, if any, are defined for each failure mode. So each of these yellow units are our architecture blocks. As you can see, we go down a few, maybe 3 subsystem levels from our system. I suppose 2 in this particular case, a simple flasher and then a power supply. However, your power supply could, as I say, be broken down into further subsystem blocks. So each of these is our architectural blocks. The blue lines are our deviations and the pink lines are our mitigations. So the next thing then we need to do for each of these deviations, we need to describe what is the potential impact of a failure for any of these deviations. The one we're looking at here in this particular example is the power supply goes high. So what is the impact? And we've described that as a dangerous fault. And the D100 basically means that all the failures for this danger are appropriate for dangerous. They're not split between any of our other impact modes or failure modes. The next thing we need to do then is look at our mitigation. Do we have any diagnostics for this particular mitigation? Now, we do have diagnostics, as we looked at in our circuit, for a low voltage or 0 volts in our power supply. However, we've no diagnostics for high voltage or high current. So our diagnostic level of effectiveness is none, gives us a diagnostic coverage of 0. There's no effective measure for this deviation, so there's no action taken as it's not detected. And we do that for each of the various different deviations and mitigations throughout our design. So once we have all this information coming from our FMEA, our device failure modes, block failure modes with device failure mode classifications, derived requirements and latent fault mitigations, added with our hardware architecture and also our schematics, bill of materials and component specifications, all this information fed into an FMEDA means that we can have a more accurate and a much faster FMEDA process when we get to that point. So in conclusion, a complete FMEA is done at the lowest hardware architecture level, and the reason for this, it can significantly reduce engineering time when an FMEDA is done. So as I said, go as low as you possibly can so that each block that you go to has a common functional failure mode or modes. Also, FMEA information is likely to result in higher accuracy FMEDA work as guesses and assumptions are significantly reduced, if not eliminated. So just to repeat, this was the 5th in this particular FMEA fall-autumn webinar series. Next week we'll have our final one on a streamlined FMEA. And as I said, don't forget, all these webinars are made available afterwards through our exida website and also on our YouTube channel. So I'd like to thank everyone for your time and attention this evening, or wherever you are in the world, whatever time it is for you. I hope you found it informative. I've a couple of questions already there coming in. So I'll address them now, but anyone, any other questions, please write them in the question box and I'll get to them. And also, after the webinar, if you find any questions coming to mind, reach out to us at info@exida.com or connect to us through the exida.com website. So Bruce there, sometimes a component in the schematic could fail but have no significant effect. So in a DFMEA, it wouldn't be considered, but the FMEDA would still need to be considered. Well, if there's no impact, we would obviously assess that and we would mark it as enunciation failure or don't care. We do look at it in the analysis, but yeah, you're correct. We still consider it, and it comes out in the metrics at the end of the analysis, but it's obviously categorized as enunciation or don't care, or it could be a safe detected or safe undetected, depending on whether we have particular diagnostics in that block of the diagram. Bruce, next question, what is the name of this software? The software that we develop in-house and use at Exida and is also available is OEMX, and as I said, incorporated into the software we have the CRD, the component reliability database as well, which allows you to do your analysis on any particular type of component that you're bound to use when you're doing product design. So hopefully, Bruce, that answers your question. Marco, question coming in there. The FMEA can contain failure mode, which has systematic cause. Sorry, should they be propagated to the FMEDA? So there's a bit more flesh to the answer to that one, Marco. And what I'll do, I have all the email addresses for anyone who attended this evening's webinar. So I'll reach out to you and come back to you with a more detailed answer to that particular question. Bruce, increasing n number of blocks raises the FMEA complexity by n. Getting into maths late in the evening for this, Bruce, but bear with me. How does the exida software manage FMEAs of electronics inside a mechanical design with its own FMEA? Does exida suggest mechanical FMEDA? Well, part of the OEMX tool, and it may not have been obvious in the actual books, the slide where I showed the books. It comes in three parts. We have components, electronic components. We have sensor elements, sensor components, and then also mechanical. So we can do a complete FMEDA of an electromechanical device within the OEMX suite. Another service that exida provide is if there's a particular component that you are using in your design, but you can't find an equivalent in the CRD within the tool, we do offer a service where we do the research and we add that to your specific database if you have the OEMX tool. So yeah, you can do the complete analysis, FMEDA analysis with the OEMX suite. Has anyone any other questions? Some very good questions there, and don't worry, as I said, Marco, I will I'll definitely come back to you. I get a copy of all the people who've attended the webinar this evening, so don't worry, I will come back to you on that particular question. I just, to give it merit instead of just kind of giving you a quick flip of an answer, I think it deserves more detail, so yeah, that's why I'll come back to you on that one. Has anyone any other questions? No, I think, oh, brilliant, Marco. Yeah, no problem at all. Thank you. Yeah. Yeah, I was just going to say, if everybody else is happy, as I say, do not hesitate to reach out at us here at exida, info@exida.com. So Bruce, can you do mechanical and electrical FMEA separately and then merge later? Yes, certainly. And I think, Bruce, you have reached out to us previously about the tool. So look, if you want to reach out again and we can kind of pick this up and give you a bit more detail about the OEMX tool, by all means. But as I say, what I might even do is just drop you an email, just that you can follow up on, and we can take it from there. So again, thank you for the interest and yeah, for the questions. If everyone else is happy, I think at this stage I'll call it a night where I am. Hopefully everyone else has a good day, good evening, and thank you for your attendance.